Example 2, find the optimum strategies and the value of the game. Remember what we're trying to do. We want it to be strictly determined. We want there to be a saddle point. So don't forget to check for a saddle point. Remember, with the row player, you check for the lowest number in each row. And for the column player, you look for the highest number in each row. It's like you're saying, what's the worst that could happen? And when you've circled and underlined the same exact number, that's a saddle point. Okay? That number right there is a saddle point. That means this game is strictly determined. It's the easiest possible case. Okay? I know everything that's going to happen. The value of the game equals 3. That means the row player is going to win, right? Think about the row player's strategy. Okay, I'm not sure that we've written it in this way before, but the row player should be playing row 3 every time, right? That's what that means. Row player plays row 3 every single time. So let's write it as a vector. Like that. That means the row player is going to play row 3 100% of the time. The column player is going to play column 2 100% of the time. So let's do this to say the column player plays column 2 100% of the time. Okay, that is the optimum strategy. Number 2, same question. So the first thing you want to do is look for a saddle point. Lowest, 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 highest, highest, highest. You can see there's no saddle point. No saddle point means it's not strictly determined, and that means they're going to have to mix up their strategies, okay? So if there's no saddle point, if it's not strictly determined, the next best thing is if this is a 2x2 matrix, we can do the multiplication thing, okay? So let's get rid of this real quick. Let's see if we can have any dominated strategies. Rows are always easier, okay? 4 is better than -3, but 0 is better than -2. How about -2 is better than -3? 1 is better than 0. 2 is better than 1. Okay, I can see that row 1 is always better than row 2. So, keep track of the ones that you've kept. We're keeping row 1 and row 3. Now look at your columns. I can see that 1 is better than 2. Remember, it's backwards for the column player. This means lose 1. This means lose 2. This means win 2. This means win 1. Column 2 is better than column 3. So I'm going to cross out column 3. And I'm only going to keep columns 1 and 2. So we can reduce this thing down to a 2x2. Now, again, you want to keep track of which rows and columns you've kept, okay? And we can do the matrix multiplication from section 11.2 here. So remember what we do. For the row player, we're going to take P times 1 minus, or not times, P and 1 minus P times this, okay? So row times column, I have -2p plus 4 times 1 minus p. That's my first entry. And then row times second column is going to be 1p, not plus, minus 2 times 1 minus p. We equalize those. -2p plus 4 minus 4p equals p minus 2 plus 2p. collect like terms, negative 6p plus 4 equals 3p minus 2. Moving stuff around, add that over, that's 9p. I'd add this over, and that's equals 6. So divide by the 9, and we're going to get p equals 6 over 9, or 2/3. P equals 2/3. That means the role player's strategy is 2/3 and 1/3. Wait a minute. Hang on, I forgot that we skipped one. Which one did we skip? Row 2? So 2/3 is row 1, and 0 is row 2, and 1/3 is row 3. Okay, that's the role player's strategy. Now we do the column player. For the column player, you have to do it like this: -2 and 1 and 4 and -2. So let's multiply row by column. And see what we get. We'll have -2p plus 1 times 1 minus p. And then we do the second row, and we'll have 4p minus 2 times 1 minus p. Now remember, we're going to have a 2 by 1 there because it was a 2 by 2 times a 2 by 1. So we should end up with a 2 by 1. That's what I have. But regardless, I just need to equalize those two things. So let's see. Look like that. -3p plus 1 equals 6p minus 2. And then I can add the 3p over and add the 2 over. So when we divide by 9, we're going to get p equals 1/3. Okay. Now keep in mind that we crossed out the third column, right? Okay. So when we look at the column player's strategy, you're going to have p is 1/3, and the second column would be your 2/3, and then the third column can be 0. We're skipping that. We're never playing the third column. Okay, so there are your optimum strategies for your row player and column player. Now for the value of the game, remember how you find that. The value of the game, you're going to multiply the row strategy, bless you, times the payoff matrix times the column strategy. So let's see. New matrix. Okay. Now we're going to have to enter this as a 2 by, let's see, a 2 by 2. And the reason why, if you look at, this is a 2 by 2, so making this a 3 by 1 or a 1 by 3 isn't going to make any sense. So let's kind of ignore that 0 there. Maybe I shouldn't have even put it in there. Just kind of ignore that and ignore that. Okay. So we want a what is this, a 1 by 2? We want a 1 by 2. And it was 2/3 and 1/3. Okay. just going to check that real quick. 2/3, 1/3. This one was 1/3, 2/3. So matrix B, -2, 1, 4, -2. And matrix C was a 2/1, and it was, what did I say, 1/3, 2/3? Okay, so let's multiply them. Make sure you do it in order. A times B times C. And we get 0. Okay, we get 0 here. So that doesn't happen very often, but that's fine. That's good. The value is 0. Remember what that means. It means that this is a fair game. This is a fair game.